Okay, so now that it's recording, yes. So once again, we're going to very quickly summarize what we have done yesterday, and we are going to put this into practice using R. So I've prepared an activity for you, and I'm going to explain it, and then you will have time to try it, and I'll give you the answers, the corrections, and we can try to move forward together. So if I share my screen, sharing screen. All right. If I share my screen, yesterday, what we've done together, you can see my screen, right? Is it working? Is it okay? Because sometimes it doesn't work and then, okay, so that's good. Okay. So yesterday I've introduced one part of NLP, and it has to do with text, and it's autocorrection, spell checking, and trying to go beyond that. So what I told you yesterday is that in many different sectors, we produce a lot of documents, of text documents. And in these documents, when you write, you make errors. That's very normal. And the point is to try to correct these errors with computers as well as we can. So how can we come with algorithms? How can we come with methods so that we can address the different types of mistakes we make when we write, or most likely when we type on our keyboard, so that the text can be better? And that's good for translation. That's good when you look for information. That's good when your supervisor or your boss or anyone else reads what you are doing, and if it's full of errors, it doesn't look so good. It doesn't reflect good on you. So what can we do? And what I've told you yesterday, if I summarize, is that actually there are different types of errors. There are lexical errors, orthographic errors, and then there are grammatical errors. And I've told you, when it comes to the orthography, when it comes to the forms of words, but without paying attention to grammar and the connections between the words in the sentence, this is easier, and we have some strategies. And when it comes to grammatical spelling, now this is trickier. This is more difficult, and we have software to do that, but it's still not perfect. So we can focus on orthographic spell checking, and then actually we can distinguish between errors that you make, but actually you know the words, but you just didn't type them right, for instance, and errors when you don't know the words. And I told you the computer doesn't know which error you are making, but usually it's easier to correct errors of performance than errors of competence. And usually the kind of things you do is that oh, sorry. Okay, I always try to mute if some noise appears. So there are different types of errors which are very common, like you insert a character, you delete a character, you duplicate a character, you replace, or you invert two characters. So how can we detect these things? What I've told you is that if you just rely on alphabetic order, very tricky, you can miss the whole point. So that's why I introduced skeleton keys, which were used in old versions of Microsoft Word, for instance. And I've told you how you can create skeleton keys and how it works. So you can compare not word forms directly, but the skeleton keys of this word form. And then you may be able to suggest correct forms for an erroneous form, for a mistake. So that's one step toward producing a better document. So I've told you about these skeleton keys, and then I've told you that there's another method which is known as the Levenshtein distance. And I have given you a method with a matrix to compute the distance between two word forms. So there is an algorithm that you can follow, and you gradually fill all the cells in the matrix. And then you look at the final cell, bottom right corner, and that's the distance between your two words. So that's how it works. If you have buffalo and buffet, then what you have, BUFF is shared, are shared between the two words, these letters, these four letters. But then if you want to move from ALO to ET, you need to drop one letter and you need to substitute two others. And that makes a difference of 3. Sometimes it's very obvious. If the words are more different from each other, then things are trickier, basically. So that's what I told you. And there are yet other methods that you may consider, like you may account for the distribution of the letters on the keyboard, because when you type, it may be easy to type a letter just left or right of the letter you wanted to type to enter. You might use some corpora of errors. That's like you may have some knowledge of the common errors that people make, and they may differ from one country to another. So we have actually corpora containing this kind of data, and you have a number of other things that you may do. Is it okay? Were you clear with all of this yesterday? Because now we are going to practice on the basis of what I explained yesterday. Are we good? Can we move forward all together? Is it okay? Or do you have any question following what I told you yesterday? If you're okay, then yeah. Is it okay, Jean-Claude, Jessica?
Yeah, it's okay.
It's okay? All right.
Can do practice.
Okay, so let's practice. Rather than I give you more and more and more content, let's practice. So I have prepared an activity for you. And let me show you the activity. So actually, if you go to the Google Drive for this seminar, you will see that I created one folder, which is activity number 1, spell checking. And if you go there, you will find 3 files. There are 2 text files that we are going to use. So you should download them on your machine. And there is a Word file, which I'm going to go through with you, which contains the instructions, the questions you have to address today. So that's what we're going to do together. So you have one file dictionary, one file text for spell checking. I'm going to have a look at them with you in a few minutes, and then the instructions. So you can download all of this to have it on your computer. So what will you find in the Word file? You will find this. So what I would like you to do is to use R to build a simple spell checker based on what we've seen yesterday. We're going to focus on skeleton keys, but if you are pretty fast, you may also try to use the Levenshtein distance. And I have tried to break this assignment into a number of questions, and we can increment the quality of our approach gradually, so that in the end we end up with something interesting, which looks like what I told you yesterday. So actually what we are going to work with, but then you could change for anything else, we are going to work with this text file, text for spellchecking.txt. So I'm going to show you this file. It's a very, very simple file. It contains some text. And you can see the text. Hello, my name is Charles. I was born in London in 1988, but I'm now living in Hong Kong. I'm married and has 1 son and 1 daughter, Theodore and Annie. Here, life is quite different from where I was born. This is a huge city which never sleeps. People are always trying to improve their conditions, but many still experiences challenging situations. Of course, when you look at this, and you can change it, it's totally up to you, I have created quite a number of errors, okay? The point is to try to automatically detect some of these errors and propose plausible corrections. To do that, we are going to use a dictionary, a reference dictionary, exactly like what I described in the session, during the session yesterday. So you have this file, and then you have the other file, which is actually a dictionary. What you can see here, it's a tabulated file, and basically it's like an Excel file, right? I mean, you should be used to that. There are 3 columns. There is one column which contains a word that exists in English. Then you have the frequency of this word. And then you have something else, which is the grammatical class of this word. Something like verb, adjective, pronoun, etc., etc. I created this file from a much larger database, a much larger dictionary, which you can find online. Actually, I typed its name in the chat. It's something that is called WebSelects. If you would find this, if you look for this on Google or I mean online with any search engine, you would find that you can download it, and it contains information about words, word forms in English. So we are going to use this file as well, because we need it to check if the forms, the word forms in our text exist, are correct or not. So that's what we're going to work with. But let's do it step by step. So I have a number of preliminary questions. I have 2 questions about the content of the text file. So when you look at this text file, I would like you to detect the orthographic errors and how you would describe them in terms of like insertions, deletions, substitutions, at least some of them. What grammatical errors you can notice. So these are 2 preliminary questions, let's say a little bit more linguistic, not very linguistic, but a little bit. And then I have some preliminary questions regarding R. So I don't know exactly how good you are with R. I guess some of you are really good because you use it all the time. Some of you may not be so familiar, but from what I got, you are all introduced to it. So I would like to build on that. To make things a bit easier, I have some preliminary questions. First, I would like you to know there is a variable which is predefined in R, letters. What does it contain? And then there are a number of functions. Maybe you know all of them already, maybe some of them. I want you to make sure what these functions are doing using help online or using help in RStudio. And you can try them just to make sure that they have the behavior you expect. And then I want you to think and try and know, how do you read in R the content of a tabulated file? Like, sorry, it's a small mistake here, a non-tabulated file. That's my bad, I'm sorry for that. A non-tabulated file like text4spellchecking.txt. So it's not like a CSV like table. So I should write it like that, sorry. All right, so a file like the one I have just shown you, which contains text, but not as a table. How do you read the content of this in R? And then if you have now a file like, oh, what did I write? Sorry, I think there was a mistake. Okay. All right, sorry for that. Okay. How do you read in R the content of a tabulated file like dictionary.txt? Because this is not the same method. You may know how to read a tabulated file. I'm not sure if you know how to read another kind of file. So I would like you to try to find how to do that if you don't know yet. Once you know this, and I will give you the answers before you move to the next part if you are unsure, Then I would like you to write a piece of R code where first you load the file text4spellchecking.txt, knowing that it's a UTF-8 file. Then I would like you to load the dictionary. It's also UTF-8 file, so it's Unicode, and it has some symbols. And you should, if you try, you will see what happens. Then I would like to look at the dictionary. Do you need to do any pre-processing? Do you detect something weird or not? Or do things look okay? And then, if we want to build a spell checker based on skeleton key, Claude, the documents are in the Google Drive. So let me just replace this version with the one with the correction right now. So it will be better. So if I remove this one and upload it again. All right. It's in the Google Drive. There is a folder, activity number 1, spell checking. If you go there, you will find the 3 files I've shown you. Can you find them, Claude? Is it okay? And yesterday I've sent everybody the access of the URL of the Google Drive. So all of you should have access. Okay, Claude, can you see them? Please let me know. Is it okay? Yes, no? Well, if you don't tell me, you should see this one. I mean, it's the Google Drive is the same folder as you, so you should be able to see it. It is okay, right? Okay. So if I come back here, you need to load the text with the file containing the text. You need to load the dictionary. You need to check if everything looks okay. Then you need to write a function which returns the skeleton key of a word, represented as a string of characters. So if we want to do spell checking based on skeleton keys, definitely you need a function like this. And then I would like you to add a column in the dictionary with the skeleton keys of all the words, because we will need that later on. And then I want you to write a procedure, a few lines of code, where you check the word forms in the text file one by one, and you check whether they appear. You check whether they appear or not in the dictionary. That's the first thing, right? If they don't appear, then you can add something more as a second step. You compute the skeleton key, and you check if this skeleton key corresponds to at least one word in the dictionary. And then if the skeleton key corresponds to at least one word, then you can return this word or these words as plausible corrections for the erroneous word form. And then you may check what kind of things you get. Does that look satisfying or not? If that's okay, if you manage this, then you can move further. And then this time, if you find that the skeleton key you have computed for the target word form does not correspond to the skeleton key of any form in the dictionary, then what you can try to do is to check close neighboring skeleton keys, and you see if you can find words in the dictionary like that, and they could be plausible correction. So we can do it step by step. And then you may try the Levenshtein distance, and then you might try something even further. So that's the later part. But let's try to do that first. Preliminary questions, and we take the questions to build a spell checker one after the other. If you are very fast, if you know R very well, then try to do everything. Otherwise, we are going to move step by step, which means that I'm going to give you a few minutes for question 1 and 2, the preliminary questions, and then I will check with you. Then I will let you check 1, 2, 3, 4, and then I will check with you. And then we move on like this, but each time I will give you some correction. I will do it on my RStudio, so we can make sure that you understand how to do it. And then in the end, you have a program which works, and I will share the correction, the whole correction after the session. Does that seem okay? Do you have any question before starting to tackle the questions? So today you are working, and I don't lecture you, okay? You are trying on your side, but then I will provide correction step by step. Is that clear enough? Yes, okay. So let's try first the first thing, okay? It's 3:28. I'm going to give you 3-4 minutes so that you tackle questions 1 and 2, the first ones. The errors you can see in the text. That should be pretty easy, okay? So try that, and then in 4 minutes, I will ask you to give me, we will check, you will give me some of the errors you have detected, and then we can move on. So we are going to move like this. So please download the files and please start. And if you have any question, of course, you can type it in the chat or let me know. And then, of course, I try to answer. All right. Somewhat. Okay, online compiler. So I kind of never use online R compiler. I can try to find something for you. Let me see. I'm not sure which one. All right, maybe this one. Okay, I think you can use this. That seems very easy. And when I tried the code, it was pretty fast. So I think that should work and be quite simple. No problem. So what are the errors that you can spot in this text? Can you give me some of them, and can you tell me whether it's an insertion, a substitution, a deletion? What do you see? Whether it's orthographic, whether it's grammatical. When we do data science, before rushing to write some code, we should always inspect our data. That should be the first thing. So what if you look at the text? What kind of errors do you see? Please don't be shy, okay? Deletion included, yes. Everything you spot. And don't worry if you get it wrong, okay? Because if you don't tell me anything, there is no way for me 6,000 kilometers away to know whether you are okay or not. So you need to help me by giving me some inputs, okay? So either speak or write, just give me stuff you find. I mean, it should not be very difficult, at least for this part. Okay, so Jean-Claude name. So there is an E missing, so E was deleted. So that's a deletion. Yeah, that's good. Different, yes, there is an insertion, right? So there should be different without final E, but there is this added letter at the end of the word. Perfect. Are these orthographic or grammatical errors? What do you think? Has one son. Yeah. Okay, so that should be have, right? So have is a grammatic error. Okay, has and have are two forms which both exist in English, but in a sentence like this, you cannot say I has one son and one daughter. That doesn't work. So that's a grammatical error. The previous one are orthographic. What else did you spot? There are quite some more. Okay, what is the kind of error here, Jean-Claude? CIYT. Replacement, you could say there are two replacements. Maybe you could call it otherwise. We may call it an inversion, okay? The Y and the T have been swapped in a way. And they are both grammatical errors and orthographic errors, yeah. Charles, okay? The problem, two S's where there should be only one, right? Charles. Okay. Some more. Improve, how do we call this error? Trying, that's yet another one. So how do we call the error in improve? It's a spelling error, yeah. Is it a substitution, a deletion? What is it? How can we call this one?
I think it's a deletion.
For which one? For trying or for improve?
For improve.
Improve. So there is two V's where there should be only one, right?
Yeah.
So we can call this an insertion. Does that make sense? Or a reduplication. Yeah, does that make sense? Mohammed?
I'm thinking, you mean duplication because there is an extra what? An extra
So for Charles, there is an extra S, and for improve, there is an extra V.
Yes.
So you have S and then you have SS, or you have V and then you have V and V. So in that case, it's a specific kind of insertion that we usually call like a duplication, a reduplication. It's just the same letter appearing twice now.
Okay.
Okay. All right.
Yeah.
Okay. Trying. So trying, it's an inversion, or it could be one deletion and one addition, but is I and Y being swapped with each other. So we should call it, I think, most commonly an inversion. Where do you think, okay, Mohammed, where do you think these mistakes, conditions, how could you explain such a weird error? Who has an explanation for such an error? So it should be conditions, of course, but now it's conditions. Do you have any idea why this error was made? Any
Probably
guess?
from the keyboard. I
Very
think,
good.
yeah.
Yeah, Uniter. Very good. If you check your keyboard, unless you have a very specific keyboard, but it's a French one or an English one, B and N are next to each other. So maybe you wanted to type N, but your finger kind of slipped and you typed B instead. Okay. So there are maybe a few more, but more or less we have them, right? There is challenging, there is, okay, Jean-Claude spotted it. So we have one letter missing. So we call this a deletion. The G was deleted, and that's how we have now this erroneous form. So, okay, we have like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 errors, something like that. How many can we detect? And for the errors that we can detect, how many can we suggest reasonable corrections? So that's the whole thing, right? That's the whole idea. If you have many still experiences, many is plural. So actually experience should be without S. Is it an orthographic or is it a grammatical error? So many still experiences instead of experience. Is it grammatical or is it orthographic? The nature of the problem should be is not orthographic. City is orthographic, but experiences. This one is grammatical. It's an issue in terms of the agreement of the verb, the singular versus plural, agreement with the subject, many. So what we have seen together yesterday is that it is more difficult to address these errors than to address orthographic errors. Okay, so this is about the text. Now, please check. I'm going to give you at least, maybe I'm going to give you like 10 minutes. Try to address these questions. So 1, 2, 3, 4 here in the second part. Letters, what is this variable in R? What does it contain? What is it? And then what do these different functions do? Plus, how do you read the different text files? So once again, I'm giving you a little bit more time this time. And if you remember, if you are using RStudio, you can very simply go to help, and then you can type something like str split. And then you can find explanations for the different functions and what they do. So that's how you may you may start, or you may just try something online because you have a lot of information online regarding R functions, but try to know what these different functions do. And then you'll tell me in, 10 minutes. So try your best. And if it's very, very easy, then just move forward. That's the idea. So Jupyter Notebook are usually for Python, but I think maybe you can use them with R as well. I'm also not, I don't do stuff online much. So yeah, it's possible, but it requires to install some stuff. Aimé, if your name is Aimé, if I pronounce it right. So yeah, you can do that, but it will take a little bit of time to set it up, basically. But yeah, that's definitely possible. All right, let's try to move a little bit forward. So what do you find in the variable called letters in R? What does it correspond to? Can someone let me know? What do you have in this variable? Anyone? If you have been using R, this should be quite straightforward, hopefully. So who can tell me, what do you have in, what is letters and what does it contain? Okay, 26 upper and lower Roman alphabet. So how can I check that? So actually I have two variables. One is called letters lowercase and one is called letters uppercase. You know that in R, and that's different from Excel, for instance, the lowercase, uppercase, that makes a difference, right? So if we stick to the lowercase one, letters, what we find are the 26 letters of the Roman alphabet. Yeah, very simple. What kind of object is that? How would you define what is this object? Is it a number? Is it a list? Is it a function? What is it? What is the kind of object is that? This is a it's a vector, right? Do you agree with that? We can see this is a vector of strings of characters. We can see the strings of characters because we have the double quotes which surround the content of each string. And we have 20 strings like this, except that each string consists of only one letter, one of the 26 letters. And we find that we have 26 elements. Okay. So if we want to do some text mining, if we want to check the composition of word forms, this is going to be useful likely at some point. What is the function? What does the function unique do? What can you do with unique? If you are using R, this is likely also a function you have used in the past. Okay, Jean-Claude, make character strings unique. Only character strings or anything else? Brings out the unique variables. So let's say that I define my vector. Okay, it contains 5 strings, A, B, D, B. If I do unique of my vector, I'm going to delete some of the elements, right? They are dropped in the order. It's used to eliminate duplicates, exactly. So now I end up with A, B, and D. Of course, if my vector would be something like whatever, right? It's not, it doesn't have to be one string, one letter per string of characters only. If I have this, then I will keep A, B, Y, Y, and D. It actually works also with with numbers. If I have 1, 2, 3, 3, 4, 5, 4, 7, 7, then I end up with 1, 2, 3, 4, 5, 7. Good. What about sort? What can I do with sort? So let's say that I have a vector 3, 4, 4, 2, 1. What will happen if I sort this vector? Come on, don't be shy. Okay, arrange variables in ascending or descending order. Okay, if you have numbers, the vector that will get you 1, 2, 3, 3, 4. Sorry, I need to use my vector 2. If I have 3, 4, 4, 2, 1, is going to sort everything 1, 2, 3, 4, 4. No problem. And if I wanted the decreasing order, I could, for instance, use another function, reverse. So I sort it first and then I reverse it. That would be one way. And if we would check the help of the function sort, you can see that you could also write something like this. Decreasing is true. And then I would get the same. I would have decreasing from the largest value to the smallest value. If you do it with strings of characters, then what is the order used? That's the alphabetic order. So we can use it to sort strings of characters according to the alphabetic order. Should also be quite useful if you do text mining, right? What about too lower? Too lower. What does it do? Okay. Yeah. Talk to you later. If I do too lower, it will take all the uppercase letters and it will turn them into lowercase counterparts. And then you have the opposite, actually, too upper, and that would do the exact opposite thing. So now all the letters are uppercase. If you have something like this, then of course the function will be applied to all the strings of characters which are found in the vector. Okay, so the function is vectorized. No problem with that. Good. What about str split? This one you may not be as familiar with as the previous one. So what can you do with str split? Did you check? And what can you do with this one? The name suggests that you can split something, right? The screen is very small. Let me try to zoom in. I mean, if I zoom more, then it's going to be difficult for you to. Okay, I can still try to make this one a little bit larger as well. Okay, so when you need to split strings into parts. Okay, so let's say we have, I came to Hong Kong yesterday. That's the string you want to decompose. And then here, the second argument of this function is the way you want to split. So here, the way you do that is by providing what we call a regular expression. Now, my question is, have you already heard of regular expressions? Is it something you know? Regular expression, or in short, we call them regex. Is that something you have played with before? Okay, at least for one. Is it the same for others? No, for Muhammad. So actually, I will teach you a little bit about them in one of the coming sessions, because this is very useful when you want to process text, okay? When you want to correct a number of problems, when you want to look for some elements. Here, if we do something like this, if we just enter like a blank space, what will happen is that you will get the blank spaces, the blanks will be used to separate this string into a number of elements. And if you check the result of doing this, you see that actually it returns a list. And in the first element of the list, you have the different here words of the sentence. Now, let's say that you would like to separate the sentence according to something else like A. Then, of course, you're going to get something quite different. The first A is in came, so you would have I space and C before. Then the A would disappear. Then you would have everything until the next A. And then you would have the final Y later. That wouldn't make so much sense, but you can use space to separate some words which are separated by spaces. What are the kind of elements we want to put here so that we can cut sentences and detect all the words? Is it only spaces, or do we want something else? What else do we want? If we want to cut basically our text and we want to extract all the words from our text, what are the other elements we should consider? There are at least 3 things that you can see here that you should consider, in addition to blanks, to spaces between words. What are these things? Anyone? What are the other elements you can see in the sentences, and you would need to account for these elements if you want to extract all the different words? There are spaces between words, but what else? And all of us use this when we write.
Separator.
Sorry, I did not get it.
I say separator, like comma.
Comma, yeah, punctuations. That's the other thing. If we have a sentence like this, I came to Hong Kong yesterday with a dot at the end. Here, you see that the final word is going to be yesterday with a dot. Or if you would have an exclamation mark, if we do that, then we don't have the word yesterday. We have the word yesterday with the punctuation. So actually, when we want to get rid of all these things or to account for all these things, so dots, exclamation mark, question marks, but also comma or maybe semicolons, we need to account for all of them. So if you want to do that, but I will teach you later on, you could do just something like this. When you use the brackets, it means everything in between. So you could have space, dot, question mark, comma, exclamation mark, semicolon. So if you do something like this, what you will see here is that the exclamation mark at the end disappears. If I have this comma as well, like this sentence, if I do that, now you see that the comma has disappeared and the exclamation mark at the end as well. There is one thing you need to do, and you will understand this better tomorrow or the day after tomorrow, is when you have two of these elements one after the other. So when you have a comma and when you have a space, or if you have a dot and then or an exclamation mark, then you have space. If you want to do that, you need to add a small plus, which means you want one element, one of these elements or more than one. So if you do like this, then you will get exactly the words you want. So if you remember that, we are going to use this later on to extract all the words from our text. That's how we can do it. So we get one list, and the first element of this list here, it contains the different words. So that's a very interesting function when you deal with text. That should make good sense, right? All right. What is the last function? What does the last function do? This function vectorize. Can you explain? Can anyone explain what it does? It's a bit trickier. It's not related to text. Have you seen this function before? Please, if you have any idea, please write it down, okay? Otherwise, we just go very, very slowly. And especially if you know it, then I mean, we just drag down, right? So if you have any idea, please just try. If you want to split by letters, that's a good question. You can do like this. If you do this, you can see the result. Okay, maybe let's say that you have a single word, because that's a bit weird when you have several, but let's say that you have something like this. You see the result, right? All the letters, they become one string of characters. So yesterday, exclamation mark, yesterday, and the question mark. If you do this, it's the same, but you see that the space, they become, okay, they are also considered, actually. Yeah, it's a bit tricky to read, but you see the first element, the second element, and so on and so on. So all the elements, they become one string of characters. So that's how you can do it. So what about the function vectorize? Anyone? What we did before, we had this, I like this, Chantal, but it's not what it does. It's more, is not also not characters. I mean, you could have functions which could do that, and maybe you could call them vectorized if you want to shift from rasters of points to vectors or things like that. But it's more like a function related to how R works. You remember I have my vector number 3. I have defined that. I'm going to redefine it. I'm going to call it vector 4. So this my vector 4, it contains 4 strings of characters. If I call the function toLower with my vector 4, what you can see is that all the strings of characters, they lose their upper letters, the uppercase. They lose their uppercase letters. So what that means is that when you do toLower my vector 4, this function is vectorized. That means that if you provide a vector of strings of characters rather than a single string of characters, what happens is that the function is successively applied to all the strings of characters, one after the other. And then what you get is a vector, as a result, a vector of strings of characters. So when you use this function toLower, by default, like many other functions in R, it is vectorized. So you can use it with a vector of elements and it will be applied to all the elements automatically. But sometimes you define function by yourself. And the way you write this function, they are not vectorized. Then if you want to create a vectorized version of your function, you just need to use this function vectorize. So let's say you create my function. So it's a small function, and what it does, it takes a string, something like that, and it gives you the length or the number of characters of this string. So I call it my function. So if I do my function of, or let's say I use one of your first names. So if I define my function like this, and I call Chantal, then what do I get? 7, CHANTAL, that's 7 letters. Okay, so it works. But now let's say that I want to apply this function to the vector, to my vector 4. If I do that, actually it works. So for some functions you define, it works from the start because and the number of characters works, is vectorized itself. But there are some functions you create and like this, it doesn't work. So if it doesn't work, what you do, you will see later on, you create like vectorize my function. So you define a new function, just something like this. If you do that, now my function, you can give it a vector of elements and it will work automatically. The function I have defined, actually, because I use nchar, it works from the start. There was no problem. But some other functions you define, it wouldn't work. You would not get a vector of results. So when that's the case, you can use this function vectorize to vectorize your function. That can be quite helpful. You will see that a bit later when we try more. Okay, how do you read in R the content? Maybe we start with question 4. How do you read a tabulated file in R? Like if you want to read dictionary.txt, how do you do that? Can you tell me which function you would use? You want to read the content of dictionary, and in dictionary, basically you have 3 columns and you have information for these 3 columns. Which function would you use to read a file like that? A tabulated file, like a CSV file, or yet something else. what is the function you would use? There are a few options, but maybe there is one that you use most frequently. Okay, read.csv, that's one of them. That's special for CSV file. Do you have a more general one? Usually in CSV file, the values, they are separated by commas. But like in my file here, the values, they are separated by tabulations. So maybe you could work with read CSV, but that's not the one I would use most of the time in this case. Which is the other one that you know maybe? Okay, you have read table. Maybe you have also this read F table. So that's another one. I'm not sure of the difference because I don't use this one, but maybe it's faster. Maybe there is something here. But read table, that can be the function to read something like my file. If I want to read this file, would you know what I should type? I should write, I'm going to call this data frame. That would be the name of my table where I'm going to store the result. I should give the name of my file. So it's actually dictionary.txt and I have a version on the G drive. If I do this, first there is a problem, but there are things that I need to specify. What should I do to make it work here? What are the options? Are you familiar with that or not at all? Have you tried that before?
Yes, we have used it.
Okay, so what are the arguments here you should provide?
I think you need to look on the separator.
Yeah.
Specify the separator.
Good. So here, if I want to enter a tabulation, what should I choose? How do we specify a tabulation? If we want to say the separator is a comma, you just enter a comma. If you want to say it's a tabulation, you enter it's a tabulation. Okay, so that's one more step. If I do that, you see that there are still some problem. It tells me, oh, line 4923 did not have 3 elements. So actually, if I go in my file and I can go far away, I can try to find what is the problem. Maybe I can guess. It happens when you read text file. If you read files with only numbers, you will not get these errors. When you read files with numbers, you would also specify something like this. Or maybe you would specify something like this. What is this? Is to indicate the decimal part. So if you are working in English, let's say if you have an English system, to separate the decimal part is usually a dot. But now if you have a computer in France, we separate the decimal part with a comma. So that's something it depends on your file. In our file, actually, we don't have numbers. We have numbers, but we don't have decimal parts. So it doesn't matter much. But yet we have some problems when we try to read our file. So if I go there, I'm not sure I see anything that would explain the problem, but there are other things when your file doesn't load very easily. There are other things you can do. For instance, oh, here there is something, is that the encoding is UTF-8. So you should write that. Encoding equals UTF-8. That's also something you should provide to R so that R knows how to read your file. So that may explain the problem. When you still have other issues, I give you some tricks to deal with that. You can do something like this. All right, and you see the errors have disappeared. Because when R reads a file, there will be some special symbols that will be possibly detected. Symbols that correspond to quotes and symbols that correspond to comments. If you check the help of read table, you will see that there are different options here. You will see, for instance, that you have quote, and basically here it means the quote can be a double quote or a simple quote. But maybe in your file you have quotes like this and they do not correspond to actual quotes like you have in R. And then you have comments, actually it's comment char. You see that by default it's this symbol. But maybe you don't have comments actually in your file. So maybe you want to deactivate this one. So that's when you can actually just add these two elements. Quote, double quote, so you don't try to detect anything. And for the comment, you don't try to detect anything. When you deal with text, these kind of things, they can help. If we enter this, okay, no problem. And now you can see that in the memory, I have df. I have an object that is called df. If I double click on it, now you can see that my elements have been loaded into R. Do you see that there is a small problem here that we should address? What is this small problem and how to solve it? We can see it if we look at the beginning of the object we have just created. What is the problem here? When you do data science and you load data sets, that's something you should always check, always pay attention, account for in a way. What do you spot here that is not so good?
I think on variable 3, first of all, we need to consider the variable names. We need to specify the variable names.
Yeah. So what is how do we do that? We need to add something, right?
Yeah, the header. First, we had to add header, and then we specify the first row. Yeah, header is true.
Good. So that's another thing, very common in data science. If you forget this, then later on, it may create some weird behaviors, and that's the explanation. So now we have changed that, and now you see that we have proper names for our columns. So I think now it looks pretty good. And if you check, you will see that the frequency of these words, that's how frequent they are. When you look at a lot of documents, it keeps decreasing. So that means that these words, actually, they are sorted by how frequent they are in English. So in English, the most frequent word you would find across many, many, many documents is the, then of, then and then you see that a appears twice. But there is a reason. That's why I kept the grammatical class for you to see that. Is that they consider a as an article, like a dog, but they also consider a as a noun. So there could be another way to use it. So we need to pay attention to that. And if you go down, you will find more and more and more of the words in English. And if you really go down the table, then you see that the frequency keeps decreasing. And we have a lot of word forms. So we have our reference terms, reference words, and we can use them to see if the words in our text file exist or not. So it goes on like this. You can see I have 160,000 forms, which is quite a lot, but for R, it's still manageable, okay? So that's what I get from my dictionary. And you will find singular and plural form. For instance, you will find dog and you will find dogs. You see here projectiles with an S, which means you will also find projectile without S, very, very likely. So we have all these elements. Okay? So that's how we can load our tabulated file, like dictionary.txt. If you try on your computer, does that work? That should work. Is it okay? Is it working if you try that? If you try this command to load this file? Is it working? Please let me know. Otherwise, I have no idea whether it works or whether it doesn't work. Okay. When you want to read the file, you need to provide the path where you save the file. So if I write D, 2 dots, and not dash, like the tab, this means that here on my computer, if I go to D, I have the file appears in D. It depends where you put where your files are located. It could be C, it could be on the desktop. So you need to provide the right path to the file, otherwise it won't be found. If you want to know, let's say that you are in a folder like this in Windows, and you have your file here. If you want to know where is the file, you can just click on this, and then you will see the path. If you would copy that in R, you could create the path you need. There is only one thing you need to do, is you need to transform these elements. And then you would add this in the end, and then you would enter your file, and then it would load in R. So that's how you can detect where your file is located on your computer. That's how you can load a tabulated file, a table, a file which contains a table, read table, and read CSV, read delim. There are a number of variants here. The point is, how do you read a file like text for spell checking? Because this file is not tabulated. This file just contains series of words which come one after the other, a number of sentences. So how do you deal with such a file? Do you have any idea how we do that? We can't use read table. We need to use something else. Has anyone tried this before? Anyone has any idea? Seems no. You can use another function, which is called file, sorry. You provide the name of the file. Here, I'm going to type the name directly. I could put it in a variable. So that's this file. And then you say that you want to open it, to read it with an R, and you say that it's a UTF-8 file. You might write it like this as well. It should work. If you do that, what did I make? Okay, yeah, I forgot to put D and this. So if you do that, you open a connection to the file, and then you can read all the lines in this file using another function that is called read lines. And if you do that, then text, if you check, it contains the strings of characters that you have in your text file. Once you are done with it, you can just close the connection and then you have it. So that's how you can load any text file which is not tabulated. There are other ways, but this is a simple way to do it. You use read lines and you use the function file first and then the function read lines. So if you want to read news articles in the form of text file, this is what you can do. If you do something like this, you have loaded into R, into the R session, you have loaded the table, the dictionary, and you have loaded your text. And then you can move forward with these two elements. And you can see in the memory, you have DF, you have the dictionary here. Sorry, I would dig dictionary, forget, we have DF, and then we have the other one. Maybe if I just start from here, I'm just going to clean, this is to clean the memory. I just read this one and I read the text. So I have DF, that's my dictionary. And then I have text, and that's my text. Now we can move forward. This empties the memory. It does not restart, it doesn't restart R, but it will empty the memory. So all the objects you have defined, they will disappear when you do that. Are you with me or are you completely lost? It's very hard for me to know because most of you don't say anything. So I don't know whether what I show you, whether it makes sense or not.
I think I might need some more clarification on this one. From the conf function, if you can just repeat the explanation. Yes, from there. Yeah. What are we trying to reach?
Yeah. So here I want to read a file which is not structured as a table. If you want to read a file structured as a table, you use read table. But this file, it just contains text. So it's just this. My file contain one line and then another line, and it's just words, just letters and characters. I want to load this into R. And it could be much longer than that. So I want to load everything that is in this file. One way to do that is you create this function, you call this function file, you give the name, you say that you open this because you want to read it, so it's an R, and you say, oh, it's a UTF file, so don't try to read it as an ASCII file. So you create this connection, that's why I call it like connection, and then you use read lines with this thing you have created. If you do that, all the lines in your file are read. So if you do that, then the text is exactly the content of the file. And
I
then
see.
close connection is just to close the connection to the file so that the file can be used by other programs or anything. Otherwise, R has some kind of open connection to the file, to its content.
Okay.
So that's not something that you use very often if you only do pure data science with tables. But if you want to start playing with text, this is one way to load text into R.
I see. Yeah. Thank you.
Okay, good. All right. So if you are clear with these different things, we have seen how to load text for spell checking. So we are done. I've told you we have loaded the dictionary. It's a UTF-8 file, so we have said that. And we dealt with some problems. So we added this quote and comment char. These are some tricks maybe you didn't know, but just keep them in mind when you deal with text. Sometimes you cannot load or even like a tabulated file with some characters, not only numbers. You try to load the file and you have errors and you don't know what is going on. You can try something like this that may solve your problem. It's quite common. So now maybe we take a 5-minute break and then you may look at the dictionary and tell me if you spot something weird. And then we should try to compute the skeleton key of a word. How do we do that? So that's what we want to achieve. If it's easy for you, don't wait for me, okay? Because I'm going quite slowly to make sure I explain clearly enough. But otherwise, you can move to process further questions. And you can let me know if you have problems. But right now, we should do this first. So maybe we take a 5-minute break. And then you work on this for some minutes. You try, you tell me what you see, and then we do it together. Does that sound good? We can try that. It's just hard for me to know how at ease you are with R, basically. I use it all the time. So for me, I'm at ease, of course. That's my kind of my daily job. But for you, I know you have some training in it, but I don't know how confident you are. So I'm a bit in the dark. Not at the same level for sure. Yeah. I don't expect you to be expert, but if you are learning like data science, you should be able like to manipulate some data frames, for instance. That could be something you do. Okay, so let's take a 5-minute break right now so I can drink a little bit. Okay, so if you have basic, then as I explained like this, do you agree that you are learning some stuff with me then? The point is that you are learning stuff, right? I don't expect you to be super expert. That's not the point. If you are more basic, can you follow my explanation like very step by step, like what I'm doing now? Is it okay like this?
I think the approach is okay, step by step.
Okay. If we were in the classroom, then I could see your faces. That would help a lot. That for next year, if I can come to Kigali, like that would have been the plan, then that would be much easier. But of course, if the first time, if you have not touched it before, then of course it's difficult, right? But I will try to do it very, very step by step, okay? So that you, even if you don't know R, then you get the logic, like how we can do things step by step. I will demonstrate that. Okay. So let's take 5 minutes and then try and we move together then. So see you just in 5 minutes. I just need to drink a little bit so my voice doesn't disappear. Okay, so I'm back. Let's try to deal with this skeleton's key thing. Okay, so what we want to do is we want to compute the skeleton key of, let's say, elephant. So yesterday, if you remember during the lecture, what I've told you is that to compute the lexical key of a word like that, or of any word really, what we could do is follow a simple recipe. So I'm going to copy the recipe here so that it's very clear what we try to achieve. And I'm going to make it simple. I'm going to skip the first part. So I'm going to write, we skip this because we don't have accents in English. So that's simpler, okay? We could do that. I can show you later how to do it. But let's say we need to follow the recipe. So we have a string of character. Let's call it my string. And it contains the word elephant. Now we want to compute the skeleton key for this string of characters. So we have actually seen the function before. So what should I do first? I should turn every letter in lowercase. How do we do that?
Lower.
That's one line, right? How should we do this? If we want to, okay, I'm going to write it actually differently. I'm going to write it elephant with an uppercase. So actually there is actually something to do. So how do we turn every letter in lowercase? Which function shall we use?
Lower.
To lower, yeah. So we can write, let's say, let's keep my string for now. Okay, or let's call it string lower. Okay, let's write. So I'm creating this one, and I'm going to write to lower my string. Okay. Now if I check the content of this one, okay. Now I don't have elephant uppercase anymore. I have elephant. All the letters are lowercase. Okay, I have applied step 2 of my recipe. The point now is that I want to sort the letters of the word elephant so that I have an alphabetic order. How should I approach this problem? What would you suggest we can do? We can use sort, but if we just do sort of string lower, if I just do that, what am I getting? I am getting elephant. If I had several words, then these words, they would appear in alphabetic order with sort. What we want is not sort words. What we want is sort letters. So we need to have the letters of the word. So what should we do first before thinking of using sort? I have introduced a function previously to try to do that. What is it? Right, okay, split and sort. So maybe we can start to do like my character, and I'm going to use this function, str split, the one I've introduced before. And I'm going to do, I want to split this one, and I want to split all the letters. So I said, I want basically to split with anything in between. So I split everything. Oh, sorry, I wrote, I forgot an S. All right. If I do that, what do I get? I get all the letters of elephant. Does that make sense? So I got all the letters. Very good. So I'm one step further. Now I want to sort them. So I can use sort. So if I do that, oh, there is a problem here. It doesn't work. That's because when you use str split, it will not return directly a vector of the element, but it will return like a list of vectors. So that's why you can see on my screen, there is this one between two square brackets, because you have vectors and you have a list, and you can have a list of several vectors. So here, actually, if I want the vector, I need to tell R to check the first element. So here I should just enter this. So please go and check this one. And if I check this, okay, now I have my vector. So if I sort this vector, oh, okay, now I get the letters in the right order. Okay, I'm nearly done. The last step, I'm going to call that my ordered letters or something like that. Now I need to remove the duplicates. So what should I do? What is the last step? Which function should I use? One I have also introduced before.
Unique.
Yeah, sure. Let's try that. So I'm going to call this skeleton key, maybe. If I do that and I check, does that sound good? Yeah, alphabetic order, no duplicates, everything lowercase. So actually with two lower, str split and sort, and finally unique, I have everything to compute the skeleton key of my string of characters. Does that make sense? Is everything is step by step, right? I followed the recipe. That's what I did.
Nice. It's clear so far, so good.
Okay.
Clear.
So this we have done for this my string, okay? Now what I would like to do is turn this into a function so that I can call this function for everything. So I need to pack all of this into a function. So what can I do? I'm going to copy this and I'm going to turn it, and then you will see. There is one last thing that we could do is if we want to like merge all these letters to have not to have a vector of letters, but to have all the letters stick to each other. If we want to do that, we can do something. There is a function in R to do that, which is paste, or we can use paste 0. And we can just say collapse like this. If we do that, you will go from the vector of characters to a single string. If you would have here a comma instead, you see what would happen? We would have all the letters, but separated by a comma. If you would have a space, then all the letters, they would be separated by space. So we can choose what we want. But if you do that, then we really have the skeleton key as we defined it in the lecture. So let's turn all of this into a function. So usually in R, what you do, you define the function like this. So I'm going to remove some of the code so that it's a bit simpler. I'm going to call it maybe get skeleton keys. And I just tell R, okay, this is a function. And I want you to compute the skeleton key of this my string. So I don't need to define elephant or anything. I just need to give it as a parameter. So the first thing we need to do, we need to say string lower, to lower of my string, like before. Then we're going to compute my char, my characters or my letters the way we want. And then we are going to create my ordered letters. And then we are going to remove the duplicates by using unique. And then we can assemble everything together and put it back into SK so that it's something slightly different. And in the end, we say, okay, we are done. We are going to return SK, and that's it. So I can close my function. So you see, I've taken what we did before step by step, except that now I've put all the steps inside a function. If I do that, my function is defined. I just load it into R. I select everything and I press Control and Enter so that it's copied under and everything goes into the memory. If my function is defined, now I can call it with whatever I want. Let's say I want my string to be elephant. If I do this and I call the function with this parameter, I get, of course, the skeleton key I had before. If I want to compute the skeleton key of one of the words we saw yesterday, like apricot with an orthographic error, we can just say same function, apricot. And then I get the skeleton key for this word form. I want something else, I can enter it as well. Maybe this function, I would not like to call it skeleton keys with an S, is a bit weird. Maybe I want to call it get skeleton key because you get one skeleton key per word. So then I should just reload it and then skeleton key, skeleton key. Of course, it works exactly the same. I want to try yet another one. Unorthodox, why not? Just comes to my mind. Okay, then I get the skeleton key for this one. Are you with me? I've just created a small function to compute the skeleton key of any word form. Whether it's correct or not, it doesn't matter. Is it okay? All right. So I have my dictionary, right? I've called it DF. I'm going to load it again. I'm going to erase everything. And rather than reading something I call DF, DF is the term for data frame. That's why it's very commonly you can call your main data frame, you call it DF. Maybe if we have a dictionary, maybe we can call it dic inside, or dict, like a dictionary, because then the name of the variable makes more sense. So we read dictionary, we read our text, we have our function to compute skeleton keys. So we have made good progress. We have everything we need loaded into R. That's good. If you do data science, very, very importantly, before trying anything, you should always look at your data. Always. So if I look at this table, there is something I can detect. You see, here, it seems that I have the same thing that appears several times. So I have some lines which are the same. So that's kind of unexpected. Maybe there is some problem in my file. And then you see, I also have sometimes different grammatical category. It just means that the data I have, maybe I don't fully understand them, but there are some repetition, and that's kind of weird. So maybe we don't want that. Maybe we don't want to keep frequency and grammatical class. Maybe that's not really important for us. But maybe what we want is that in Word here, we would have only a form appearing one and only one. Does that make sense? there is no need to have repetition, right? Because then we have way more entries that maybe we should have. And then the table is bigger, and maybe that slows everything. So how can we do that? Any idea what we should do? What should we do if we want to keep only one occurrence of a word form in the table? We are not going to use the grammatical class. We are not going to use frequency that much. So maybe we don't want that. If we type something like this, we have seen unique before. What happens if we try unique of dictionary? It does something, but it's not very clear what it does. We can have a look. We can try. We can try that. We can call it dict reduced or dictionary unique. And we just say unique like this. We just call unique for our dictionary. Okay, we can try that. It creates something else. We can see it in the memory. And we can see that actually it is much smaller than what we had before. Before, we could see that if we go down, for instance, we had was appearing twice as a verb. Okay. So if we check what we have just created, do we still have this? Oh, here I have it only once. No, not twice. Before, if we would go down, we would find something that is repeated many times. Where can we find that? Okay, we had 22,393 times as a verb. We had many times the same thing. Do we still have this? We go down. Oh, now we have had only once. So when you use unique, you drop the rows which are duplicate. That's quite nice. Okay, we can do that. That's quite good. So now our table is much smaller and all the rows are unique. That's quite good. However, we still have this thing that more can be considered as a pronoun sometimes or as an adverb sometimes. And then the number is the same. So maybe the frequency is not so good. Okay, not perfect. So we could try something slightly different. What if we would we would only keep the first column? So if you want to get the first column in the data frame in R, you can use $, and then you can enter the name of the column. If you do that, now dictionary is going to be something different. Actually, if we do that, we are actually getting a vector. So we no longer have a table. That's not so good. If you want to remove duplicates in columns, so you can use this unique, that's one option. So I'm going to reload dictionary. So that is I have it back at the same place. When you have something like this, you can use unique. I think you can also use something that is called, maybe it's better actually. It's called distinct. So if we would call it Okay. I think unique, it works, but maybe a function that is better, I mean, that correspond more is this function. It's called distinct. So if you enter distinct and you give your table, now if you check, you will see the same as before. So had, you will have, for instance, only one occurrence of it. That's possible like this. And actually, if we want, we don't know so well, we can look in the help what we have for distinct. And you can see that if you check the help of this function, you need to provide the data frame, okay, or something like a data frame. And then actually, you can provide the variables to use when you want uniqueness. So actually, we could try something like this. And here I am going that I want to check only for word. So I want to have really only one instance of each word. That's something a bit different. So if I do this, something went wrong. Let me see if I'm okay. Oh, sorry. You should just write it like that. So you just give the name of the column directly. Okay. Now, if I do this, you see that on the right side in the memory, this table only have 88,000 elements. That's much less than 160,000. And that's less than the one from before, which had nearly 100,000. So I guess that worked, right? So if we check, we can click on it. And here, you will find that we don't have reduplication anymore. And it has kept only the column I wanted. So that looks pretty good for what we want to do. Now we have a data frame with only one column, which is word. And all these elements, they will be unique actually. So that's one way to do it. We can use this function distinct, and then we can tell which column we want to work with. And then we are going to get the result we want. Does that make sense? So this is a function that we call distinct. If you check the help of this function, you see that actually it comes from one package of functions, which is a very common one when you do data science, which is dplyr. So actually, if I restart my R, if I restart the session, so I'm using restart R, and I remove everything from the memory, I load the dictionary, I load the text, I create my function get skeleton key, and then I try to use the function distinct. You see that, oh, I cannot find the function distinct. So if you want to use this function, first you need to load the package, which I think if you have tried R, this is something you have learned at some point. So usually the package, if you haven't it already in your computer, you need to install it, and you just type its name, and then you put install, and then it will be installed on your computer. Once you have done that, at the beginning of your program, usually that's where we put it, we can just say, okay, I want to use the functions of this package. It tells you something, don't need to worry too much. But now you've said, okay, all the functions of this package, now they can be used because I've loaded them into R. So if I go there, and I use distinct now it works, no problem. And if I want to apply distinct and consider only word forms, I can do that as well. And now I get what I want. So DPLYR, exactly, yeah. This is a very, very useful package if you want to do data science. Very, very, very useful. It contains many, many, many functions to make your life easier. Do some of you know of this package? Those of you who have done more data science before, like more practice with R, is it something you use?
Yes, we do use that package.
It's kind of, and it belongs to something bigger than that, which we call tidyverse. And that's very powerful. You can do a lot of things with tidyverse. So the way you write your code, when you use tidy, this tidy approach, you will write things a bit differently. And that's so if you are familiar with that, here, for those who have tried before, you may write something like this instead. You use this, what we call pipes. Or you would use something like here for this one, you would write it slightly differently. You would say dict, and then you would write just the second, the other element. So the first element comes in front before the pipe. This is more advanced, but this is very powerful. This is very nice when you get more familiar with R. So that's one way to move forward as you learn more about data science and R. What we call tidy approach, and you use pipes, and that's how it looks like. But I keep things simple. I just tell you distinct. You can just use it like this. That's how it is described in the help anyway, in the first place. So now, if I do that in this element, I can check the summary if I want to know what is inside. Okay, it's a table, a data frame. It has one column only with 88,974 elements. And these elements are strings of characters. All right. Now, how do I compute the skeleton keys for all these elements? Because that's what I will need later on. I want to be able to check the skeleton key of my words, compare them to the skeleton keys of all the words in the dictionary. How could I do that? What is the approach you would recommend? What should I do here? I have this data frame, one column with words. I want to compute the skeleton keys and keep them for all these words. For those who know a little bit better, what is my logical next step? What should I do? What would you do? What would be your next step? Anyone? My next step would be to have a second column in my table. And this second column would contain all the skeleton keys of my words. And I made I missed a T here. So maybe I want to create this again. So how should I do that? I want to create a second column and I want to put all the skeleton keys of my elements in this column. If you would use another language, basically you want to start with the first word and compute the skeleton key. Then you want to check the second word and then you want to compute the skeleton key. Then you want to check the third word and you want to compute the skeleton key. So you want to go through all your words. That's how you could do it. So if you would use another language like C++, you could do something like this. I want to have a loop, and I want to go through all the words. So I'm going to create a loop, and I will have one variable I, because usually you call it I, and you are going to check all the rows of my table. So here, for instance, if I would print this, so I'm just going to do something not so smart, but I can try. Here, if I do that, and I start these two lines, I'm going to print row after row. So when I first equals 1, then I'm going to look at the first row, and I'm going to print the element in the column word. Then I will become 2, and I will print the second row. Then I will become 3, and so on and so on and so on. So if I do that, you see what happens? My stuff is running and everything is being printed. It takes some seconds, but I've printed all the words. Okay, no problem. So what I could do, instead of printing everything, I could get the skeleton key of everything. So for instance, I could say, I'm going to put brackets so I can write everything in detail. 1 is the starting point, and this is the ending point. So I will take the value 1, then 2, then 3, then 4. And this n row, as the name suggests, tells you how many rows you have in your table. So if I try here, actually I can try like this. If I try this, it tells me the number we have seen before, 88,974. So n row is another very common function when you do data science. It's a function which gives you the number of rows in your table. 1 is the starting point. So what you could do is you could write like something like this, row number. So you could create a variable, and then here, instead of writing the function, you could write this. It looks a little bit simpler. Starting point, ending point. If you go beyond the last row, you will create an error. If you want to know the number of columns, then of course you have the similar thing, and col. Here we have 1 column only, so the result is 1. So here what we could do, we could say, okay, I'm going to create a skeleton key, and I'm going to call my function. Get skeleton key. And here I'm going to use what I printed before. So if I do that, I'm calling my function with the word on the row number I, and I store the result in SK. Then I print the word, and then I print just below, I print the skeleton key. I'm not going to do it for everything. I'm going to do it for the 101st rows, let's say. Why not? Let's try. What do I have? Okay, I have many stuff that is written. The first word actually is the. The skeleton key is EHT. The second word is off. The skeleton key is FO. The third word is end. The skeleton key is ADN. Seems to work, right? So I compute all the skeleton keys for my words. But now I just print them. I don't store them. So what if I want to store them? That would be much better. I would need a column to do that. So one way I can do this is I can say, okay, I'm going to create a new column, and I'm going to put 0 inside. or I'm going to put NA or something like that, which means an undefined value. If I do that, now, if I check my table, you see that in my table, there are now two columns, word and SK. And for now, SK is full of NA values. But at least now I have a column and I can start to replace these values NA step by step, one by one, with the value of the skeleton key. What I could do here, rather than printing stuff all the time, I could say, okay, I compute the skeleton key for the word on the row number I. And now on the column SK, I am going to store the skeleton key. And I'm going to do this for all the rows. I compute the skeleton key and I store the result in the second column that I've just created. And I do it, start with I equals 1, then 2, then 3, then 4, then 5, until the end. And I start this. It takes a bit of time. You see, my computer is running now. It runs, it runs, it runs, it runs, it runs. It will take some time. It's quite slow, actually. You see, it takes a lot of time. Now it's done. Okay, I want to see the result, right? I check the stuff. It's here. What do you see now? All the words, and next to them, we have all the skeleton keys. So one row, one word form, and then the second column for the same row, we have the skeleton key. Very good. We have exactly what we want to move further. Are you with me? If for you this is easy, then you should not wait for my explanation. You just go, you should just move forward. Now I'm doing it very, very step by step, so that if you are not too familiar with it, you see how I gradually make it. If you are using,
we are happy with the approach. I think it's
okay. It's good like this. Okay, perfect. Okay, so I'm going to teach you something very important now. If you want to use R more, people who use R quite a lot, they would never do that. Okay, they would never do that because it takes way too much time. I'm going to show you how we can. Okay, let me just add this. Okay, I'm going to do a little something here. You see, I'm going to put two things in front of my and behind my loop. Because when you do data science, if you have very small data sets, you can do whatever you want. It will still be fast because today computers are pretty strong. However, the larger if you have a very large data set, then some approaches will be too time consuming compared to others. So from time to time, you want to measure how long things take to be computed. So here you see I'm using a function which is called system.time. If I use it just like this, you see what it gives you. It returns the current time as my computer knows it. 16th of February, 5:27 CST. So that's the time in Hong Kong, basically. 6 hours difference with Kigali. So what I can do is I can measure, I can get the time before I start my loop and I store the result in start time. And when I finish my loop, I collect the final time. And if I compute the difference, I'm going to know how long this stuff takes, provided I execute everything at the same time. So let's try that. I compute everything again. So we saw last, like 2 minutes, 5 minutes ago, we saw that this takes time actually. So let's see exactly how long it takes. It's a loop. So R iterates the loop how many times? Around 90,000 times, because we have around 90,000 words. So if we use this, you see, it took 28 seconds. Maybe it's acceptable because you need to do it only once, but maybe you don't feel that's so good. Can we be faster than that? The answer is yes, we can actually be faster than that. Because R is a language in a way which doesn't like loops very much. There are other ways to do that. If you know a bit more, you could try something like this. Okay, this column where I want to store skeleton keys, I'm just going to call the function skeleton keys, and I'm going to apply it to the column which contains words. Just before I do that, I'm going to do that with a slightly different function. I'm going to use the function which computes how many characters are in a string. And I'm going to say, okay, take the column with words, apply this function, and store the result in a new column. If you do that, oh, it didn't like it. So what is wrong with that? I'm doing some stupid thing here. Let me see if I try this one. Oh, sorry. I'm very stupid. It's not df because I've changed that before. It's the other name there. Okay. Sorry. Try the same thing with the right table. So I do this. Okay. It's done already. Let's look at the object in the memory. It's not this one, it's this one. You see what has happened? A new column has been created with its name. And then if you would check with 4 letters, so you get 4. I go somewhere else in the table. Okay, political, P-O-L-I-T-I-C-A-L, 9 letters. That's exactly what I get here. I didn't need to use a loop. I just directly called the function and gave it the name of the column. If I wanted to create a loop, I could do that. I would write something like this. And the char, something like that. And I would use the thing like this. A little bit like, I mean, very much like what I've done before, but this time not with the function skeleton key, but with the function nchar, which counts how many characters in a string. I could do that. I would get the same result. Now the question is, would it be as fast or not? We can try that. Let's try. So we do this and we measure the time. So let's try this first. So now we are using a loop. It took a bit more than 11 seconds. Now let's try the second approach. I'm taking the time just before. I'm taking the time just after. But this time we don't use the loop. This time we use directly, we use the function and we give it the whole column. How long does it take? It takes 2 milliseconds. If you compare 2 milliseconds with 11 seconds, quite obviously one approach and one of the two approaches is much, much, much better than the other. It's actually 5,000 times faster. That's why in R, you tend to avoid loops because loops take too much of your time. Does that make sense? You see my demonstration step by step. I measured how much time it takes with a loop, which is the standard approach in other languages like C++ or C, these famous languages, or Fortran or this kind of thing. And then I use something more R-like. I just call the function with all the elements in the column, and that's a big vector of many, many, many strings. If I do that, I'm 5,000 times faster. So if you are with me, maybe the next step is to use our function getSkeletonKey in the same way we have used the function nChargers before. We just say, okay, I want to compute all the skeleton keys, and I want to compute that. I'm going to apply my function to all the elements, all the strings of characters of my column, the column which is called word. Does that make sense? Are you with me? We want to do it step by step, right? Okay. If we try that, oh, it works. Okay, no problem. Very happy. Seems very fast. All right. Let's have a look at the result. So the result is here. What do you see? There's a problem, right? EHT, that's the skeleton key for the first word. But now what do I see? I see that this skeleton key appears for all my words. That's not what I want, of course, right? So there is a problem here with my function. When I try to apply it to the vector of all the words in my dictionary. Damn, okay, doesn't work. It worked with nchar. But when I want to use my own function that I created myself, this getSkeletonKey, it doesn't work. What is the solution here? We have discussed this 1.5 hours ago. Do you remember what we said and what could we do here so that we can solve this problem? I have mentioned that before. And there is something we can do quite easy to solve this problem. What should we do? You remember I asked you to check different functions. What is the function that we need here to solve our problem? Is it unique? Not really. Is it sort? Is it to lower? Is it str split? Is it vectorized? Any idea? I can try like this actually. Yeah, anyone?
Try vectorize.
Sorry, I didn't get it.
I say Do you mean we can try vectorize and see?
Yeah, that's the function.
Yeah.
Actually, we can try like this, just that you can see that where is the problem. Here, I tried the skeleton key of apricot. If I try the skeleton key of apricot, it works. Good. I tried the skeleton key of elephant. It works. But now if I create a vector, and this vector contains apricot and elephant. And now I try my function get skeleton key with my vector. What do I get? I get only one element rather than two. That's because my function is not vectorized, unlike nchar that we tried before. So we can use this function vectorize. We are going to call it, okay, I'm very careful with the names. They are quite long, so, but anyway. All right. So I tell R, okay, take my function get skeleton key and create a new function, which is a vectorization of my function. So that now I could use this new function with a vector of elements. So I can do that. Okay, R says nothing, he's happy, it's happy with it. And now what I can try. Let's try again with my vec. Perfect. I get two answers. It's a named vectors, but you can see what you see, apricot and elephants are the names of the two elements. This is a small addition I get with this. And I can see that I get a vector of two elements. And these elements are the skeleton keys of my two words. Very good. So this one didn't work so well. But now, if I try this, and I don't call my function, but I call the vectorized version of it, which I have just created with this vectorized function, what do I get? Now, if I check again the table, okay, now it works. All the skeleton keys are correct. I have computed them as I wanted to do. Very good. Now it works. Let's say I want to know how long it takes. If you remember, when we used the loop, it took around 30 seconds. If I use this method and I measure the time, it takes 1 second and 95 seconds, basically. Before 30 seconds, now a bit less than 2 seconds. So it's not as impressive as with the function nchar, but I've still divided the time it takes by more than 15, which is pretty nice. Because if my table gets very, very large, then 15 times faster is a very, it's very good. It's something I want. So when you create your own functions, sometimes you need to vectorize them, and then you can use this vectorized function to do that. That will help you to have only one line of code rather than having 3 or 4 lines with a loop. Plus, it will be much faster. Okay. What are we doing here? We are doing some pre-processing. We are doing some data processing with R. So we are doing some data science, except that we don't play with numbers. We play with strings of characters. So we are doing data science meets NLP in a way. And like this, took a while, but we have answered our 4th and 5th questions. we have added a column in the dictionary with the skeleton keys of all the words. Are you with me?
Yes, we are with you.
Everybody is with me? Okay. So you see, we are gradually making progress, okay, toward building the spell checker. What we want to do next is we would like to consider all the words we have in our text. So our text is here. We have 2 sentences and we have many words inside. And we would like to check these words one by one, whether they appear in the dictionary. So first, we don't need to worry about skeleton keys, but first we need to do a direct check. If we find the form in the dictionary, then we are okay at the orthographic level. Grammatical errors, that's a different thing, but at least we know at the orthographic level. How do I go from my text where I have strings of character, where I have 2 strings of characters? How do I extract the words? Which function should I use here to extract the words? Something we have used already. What is the function? Okay, let's try unique. If I do unique, I get exactly the same thing because my sentences are different. So they are different. So they're both 1 and 2 are unique. Because I'm looking at the whole, at the whole strings of characters. What I would like is to extract the words, have the words one by one in a way. How do I cut my sentences in smaller pieces? All right. str split. Same we have used. We can use it to extract the letters. We can use it to extract the words. You remember? I need to tell what are the elements between the words, the elements I use to cut the words. If I enter space, okay, I get something. For the first sentence, I get, hello, my name is Charles. I was born in London in 1988. It's not bad. And then I get it for the second sentence, all the elements. So you see when you call str split, if you have several sentences, several strings of characters, you get the first element of the list for the first string of characters and the second element of the list for the second string of characters. What is the problem here? Same problem as what we have seen before. What should I do? Do you remember? I cannot only pay attention to blanks, to spaces between words. I need to pay attention to punctuation. Yeah. So that's what we have seen before. This you don't know yet. I will teach you in a few days. But let's say I want to check space and column and comma and semicolon and maybe 2 dots and dot and exclamation mark, question mark. Okay. If I do that, now I'm trying to account for the different punctuations that can separate words in addition to blanks. This is better, except that I get some empty string. And this has to do with the problem that you can have exclamation mark and then a space, or dot and space, or comma and space. So I want to separate words if in between them you have one element, but it could be two of these elements. So that's why you need to use a plus here, but that I will explain once again when we see regular expressions a little bit later. So if you do that, now, that's nice. We have all the words in our two sentences. So I could call it like my words. If I do that, my words, it contains two lists. So if I want the first list, I can, the first element, it's a list with two elements, two vectors, sorry. If I want to see the first vector, I do this. If I want to see the second one, I do that. If I want to, sorry. If I want to combine, I can use a function which is named unlist. That's one possibility if I want to do that. Or I could write something like all my words, let's say. Okay, I could do that. That will work. All my words, and I ask unlist. So I want to destroy the list structure. Or I could say, okay, it's a vector, and it's a combination of the first vector and the second element, the second vector. If I do that, that would be exactly the same. So basically, if I don't want to keep the structure, the list, I can just combine everything. And now I have one vector with 65 elements, and they are all one after the other. That's maybe good enough for what we want to do. Jean-Claude, the text was imported into R by using a function before. That was here, I explained before, by using this file and read lines. So I open the file, then I read all the lines in it, and then I have my text, and then I can close the connection just for to keep tidy, to have a clean code. It can read any text file. These 3 lines, 4 lines, they will read everything, and then you will have the sentences loaded in R in text. That would be a vector of strings of characters. What I have done now, I have moved from text to the words, and then I've put, because when you do that, you have a list of vectors. I have used something else to put everything together, and then all my words are here. So what I could do now is I could take one word after the other and check if this word is in the dictionary or not. That would be the next step. Maybe, do you want to continue this tomorrow? Does that sound like a plan? But then we have 10 minutes if you have questions to make sure that you have learned something correctly today with it. I do it very, very, very step by step, okay? Very much step by step, because some of you are not very familiar with that. You see how I move gradually forward. It's a data science approach. I load my data, I clean my data to make them how they should be. I define the tools I need because they are not readily available. Like I had to create a function to compute skeleton keys. I use this function to generate new data. And now I am making progress. I have my words. I have my dictionary ready. And now I want to check if my words appear in my dictionary. I'm going to do that, for instance, with a loop. That is possible. So we can try that tomorrow. And we just move on like this. Sure, yeah, I mean, I have all the text. So I will have a full detailed correction. Like if I, okay, it's, where is that? because I prepared that before. So in the end, I will show you the whole thing and everything is well explained already. But I can also maybe annotate quickly this code so that you can have. Okay. Can you make categorization of words, Jacques? What do you mean by categorization? What do you mean by categorization? Because that could mean many different things. That could mean many different things, categorization of words. You could group words according to their grammatical categories. Or would you classify words? Yes, Élisée, then how would you like to classify them? Combine the words into one meaning. Depends what you mean by meaning. Because actually meaning in text mining is a difficult concept. So here I have all my words. I'm not sure what you would like to do with them. Can the computer get some sort of understanding of the two sentences? In a way, not really. That's why they are computers, and that's why we are human beings. Computers, they are not like us, right? When it comes to meaning. We can have some approaches to check whether some documents, they tend to be kind of similar or not. Yeah, we can do that. Later on, I will tell you about topic modeling, where you try to extract topics from documents. And I will have a software so that you can try it. Yeah. Unless you can further specify your question, I cannot really answer it, basically. Any other thing you would like to ask before we end today's session? And once again, I'm going to send you what I typed, and then you can try at home, and then you can try to modify. And I always tell my students, if you want to learn a programming language like R, it's like if you want to learn another language. Okay, you want to learn German or Chinese. You cannot learn just by reading a book, right? You need to practice. You need to change things. You need to try different things, build different sentences, combine different instructions. That's how you get to proficiency. It takes a while, just like when you learn German or Chinese. But actually, it takes less time than that, which is fortunate in a way. Anything else? Please don't be shy, okay? I'm here for you to learn as much stuff, use as much useful stuff as you can. So anything you want to ask before we end today, please do it.
I think on my side, I'm okay. This was a good approach. We need just time to go through the codes and familiar with it.
I thought maybe you were, I mean, globally, on average, maybe you were more experienced in R than that. But indeed, because I don't know I don't know your study program in detail, then it's hard for me to assess. I could see from the website that, I mean, some students, MPhil, PhD students, they are obviously pretty advanced data scientists. But then, of course, I don't know. I discover, right? It's the first time I do this with you and from afar, not being in Kigali and not having that much time. But what we can do is tomorrow we continue with that slowly, and I build on this. Then and then maybe tomorrow I can also tell you a bit more about regular expression, because that's something very useful to process text. So I will tell you a bit more about that. And then I will tell you more about text mining, but then I have some tools we can use that will make your life simpler, so that even if you don't know how to program, you can still learn about text mining by using the tools that I have created. That's the idea. So for that, you will have to install some packages on your computer. But if you have RStudio, that should be okay. I can build a version of my program that will work quite smoothly, I would say. Okay, shall we conclude for today, and you can have lunch and I will go home soon. Is it okay? Okay. Okay, perfect. So see you tomorrow at 9. We'll continue that. Let me comment. I will try to do it right now so that I can send it before I leave my office. You will find it, and the recording also of the session. I'm going to stop the recording now, but also I will add it later on tonight. I will add it so that you can access it if you want to review that.